Okay, so topic of the day is something about LLD and something about concurrency that helps software development engineers to crack interviews and, of course, to better at their jobs, right? So what we'll do is we will first try to understand that how a low-level design problem is different from a regular programming problem. So when I say regular programming problem, it could be anything. It could be something which is based on data structures algorithms, or it could be based on some ad hoc logic also, which just requires you to probably know some language constructs. And as long as you are comfortable in translating your logic into lines of code, you are able to solve such questions, right? But what happens, like if you are a fresher, if you have very less experience, or let's say mostly you are a fresher, then you are generally expected to, work on very specific things. What I mean by specific things is that maybe your team lead will ask you that, hey, this is the function, and I want you to implement this function so that it is able to read a file and convert the data inside that file into maybe a JSON or XML or something like that. So, do you see this task is very specific? I mean, you don't have to put your head into the design stuffs here. You just have to put your head into probably understanding the file handling functions and using those to read the file and convert that data into some object, something as easy as that. Yeah. But as you grow up the engineering ladder, the complexity of things start to change. What I mean by complexity is that things or questions, they become more generic in nature. They become much more open-ended in nature. So in that case, you should be able to write a code which is very extensible. Now, the most important thing is extensibility here. So let's take the previous example only, where somebody asked you that write a piece of code which reads some data from a text file and converts it into JSON. So if you are a fresher and you are able to do that, good. You will get good points for that. But if you're not a fresher, if you have some amount of experience, and let's say you are interviewing for senior SDE role or SDE2 roles, or even for experienced SDE1 roles, who have usually 2.5 years of experience, or these days even 1 year of experience, then in that case, the nature of question will be a little different. The nature of question will be that design a system which can read text file from multiple sources. Now, that source could either be, your own local machine, or it could even be that you have to read from cloud, or you have to read from database, and then you have to convert into a certain desired format. So it could be a JSON format in which I want the data, or it could be XML format. So when the requirements become much more generic means key, it simply means that, I want your code to support this thing, but it should also be able to support some other things. Yeah. Okay. Now, does that make some sense? I mean, whatever I have said, does that click in bits and pieces at least? After that, I can take a concrete example, a concrete question, which probably will make things understand better. Cool. So we will directly take a question. Everyone here is comfortable with DSA, like the basic algorithms in DSA, like DFS, BFS, and basic recursion and all. Everyone understands those things? Okay, good. So we will take a very easy problem, a very, very simple problem. Okay. So for that, I'll just share my screen. Let's say let's say you are sitting for an interview, and somebody gives you a very easy question. The question is that, what I'm going to have is, I'm going to have a graph, okay? And this graph will have some nodes and edges. Okay, something like this. So this entire thing is one graph, okay? This entire thing is one graph in which these circles are nodes and these lines are edges. Now, you will be given a source and a destination. Okay, this is what you will be given. Now, what you have to do is you have to tell me whether or not there is a path from source to destination. If there is a path from source to destination, you should return me true, else you should return me false. So what should I return in this particular case? Do you see there is a path? Yes or no? Here you should be returning false, right? Why? Because there is no path. Correct? Okay. So how do you solve this question? Considering it as a very, very simple DSA question, how will your approach look like? DFS is, I think you're asking whether the graph is connected. No, it's not necessary. The graph may or may not be connected. Okay, so you can use DFS or BFS and solve the problem. You have been given source and destination. Somebody tells you that this particular node is the source, this particular node is the destination. So they have been given to you as a part of input only, right? And then you have to tell whether there is a path from source to destination or not, right? Okay. So यहाँ पे you can use graph traversal algorithms like DFS, BFS, and you can get your job done, right? But let's say you don't know DFS, BFS, you just know basic recursion. Basic recursion ही आता है अगर. So in that case also you can solve it. है कि नहीं? Yes or no? The basic idea of recursion would be something like backtracking, है ना? Where you can first visit all the nodes that are connected to this, then you can visit all the nodes that are connected to this. So recursive calls, it's just like simple recursive calls which we'll be making, and we'll explore whether we could reach from the source node to the destination node or not. Now this way the job would be done. Very simple question. All that you have to do is you have to write a very simple recursive method, and that recursive method should be able to get you through, right? So if you imagine a function, that function could probably be written like this, that there is a function can, let me increase the font. So let's say there is a recursive function called as can traverse. Now this, let's say take a node, the current node, okay? And apart from that, it also takes the adjacency list of the graph or the adjacency matrix of the graph, and then somehow gets the job done for you, okay? So here your recursive code will come. I'll not teach you recursion here, because if I start teaching you recursion here, entire time will be wasted there. So you can use your recursive logic to determine whether or not there is a path from beginning till the end or not. So to start with, you will pass current as source, and you will see whether your current becomes equal to destination at some point of time in the recursive call or not. If it becomes, that means there was a sequence of path. As simple as that, right? Now, somebody changes this question for you. So now you are no longer interviewing for SDE1 role, you are interviewing for SDE2 role, okay? Or you are an experienced software developer, okay? In that case, the question which might be presented to you would be very different. So let me present that question to you now. So I'll just remove whatever is there on the screen, and then I'll restart. So listen to the question very carefully. What we want is, we want to design a game. It's a very common kind of LLD question where your interviewer asks you to design a game. Now, this is a very special kind of game. And in this game, imagine there is a blank space. It's just space, the universe. And in the space, there are certain points. Call those points as islands. So this is an island. This is another island. This is also an island. These are all different islands. Now, usually island is something which is surrounded by water body. Here, my island is surrounded by space. Just think of it like that. It's just like a game, right? Mobile game to play for fun, right? So now here, the thing is that there are connections between these islands, okay? And those connections could be of different types, okay? So you have got a roadway connection, you have got a waterway connection, and then there can be some maybe desert connection, There are different kinds of connections. So imagine that there is a road which is connecting this island to this island. Okay. There is also a waterway which is connecting this island to this island. Now let's say there is another waterway which is connecting this island to that island. And then there is a roadway which connects this to that. And then again, there is a roadway which connects this to that. Acha, these edges for now are directed edges. So directed edges means that there is a direction to it. So you can traverse from here to here. You can traverse from here to here using waterway. You can traverse like this. You can traverse like that. This. Let's say there is a waterway connection also from here to here. There can be multiple roadway connections also. So let's say there are two different roads that are connecting this to that. Now, let's say there is a waterway connection from here to here. And then again, there is another waterway connection from here to here. And then there is a roadway connection also. Okay. There can be desert connection also. Because see, it's a game. So game mein to things are imaginary only, no? So I should be able to, as a game developer or as a gaming company to impress my players, I should be able to introduce different forms of connections in the updated versions of game so that people continue to love it, or introduce new connections in the new levels of the game as they move on. Now, at each island, there is a vehicle. So let's say you have a car over here. You have a boat over here. Then again, you have a boat over here. Then you have a tractor over here. So you have different vehicles at different islands. This is the situation, right? Now, when you talk about these connections, then these connections have different properties. So what I mean by property is that, let's say there is a road which is connecting this island to that island. Then there is a property of this road that it cannot bear a weight which is more than 500 kg. So it means that if you have a vehicle over here on this island, let's say that vehicle was a car, for example, and let's say the weight of that car was 600 kg. In that case, it should not be possible for you to move from here to here by this path. But let's say there is another road also where the weight limit is 1000 kg. If it is 1000 kg and your car is 600 kg, then you can definitely traverse from here to here. So what I'm intending to say is that there may be different roadway connections across the islands, and they may have different weight limits for them. Okay. Similarly, when you talk about waterway connection, the waterway connection, maybe we can introduce some, some nuances. Maybe there is a waterway connection in which the water is very turbulent and only certain boats can pass through it. So only speed boats are eligible to pass through it. The normal boats are not eligible to pass through it. Do you see what I am trying to do? As an interviewer, I am trying to intimidate you to build an application where there are going to be so many different things, right? And the question that I am actually asking by the end of the day is exactly same. The question is that you are at a source and then there is a destination, and all that you have to tell me is true or false. You have to tell me true if it is possible for you to somehow reach from that source to this destination. Otherwise, you have to return me false. So this is what the question is. Is it making some sense, the problem? You can just type in yes or no if you get that. Okay. So what do you feel when you look at this question and let's say you don't have an idea of low-level design? How will you attempt to solve this question? Will you be able to solve it by this simple hard-coded logic that you had here? Isi se kaam chal jayega kya? The answer is no, because there are so many different things that have been introduced and I'll need to take care of them, right? Now, further see, think of it in this manner. Let's say this is one island, this is another island, and then there is a waterway connection. And here you have a car. So if you have a car, will you be able to traverse from here to here, given that it is a waterway connection? The answer is no, right? Okay. What if, let's say this is your source, that is your destination, and this is a roadway connection, and here you have a boat. Now, the interviewer may tell you that, it is a game, and in game, there are two kinds of boats. So first kind of boat is a normal boat, and second kind of boat is that which has got wheels underneath it. So if you want, you can launch those wheels. So if you have a boat, only if that boat has got wheels, and on top of that, if the weight of this boat is smaller than the weight limit of this, then only traversal can be possible. Otherwise, traversal cannot be possible. So do you see there are different conditions for different connectivities and for different vehicles also. If you have to manage these differences, you will ideally need to put so many if-else conditions inside your actual code. How many of you can already envision that so many if-else conditions will come inside our regular code if we have to take care of all these nuances, right? And even this adjacency list, in regular case, your adjacency list is nothing but it is just a vector of vector or maybe a list of list. ऐसा ही होता है ना? This is all that you have. But here, can you just have that? Can you just manage to have a list of integers or a vector of integers? No. If you have that, how will you identify which kind of connection this is? So what will you want? Will you want a separate adjacency list for road, a separate adjacency list for water, a separate adjacency list for desert? Yes, this is one way. ये एक काम चलाओ तरीका है. This is one way. But would you ever want to write such a piece of code? The answer is no. Because in that case, tomorrow if the gaming company says that, I want to introduce one more kind of connection, maybe, let's say, ether connection, that there is some ether and you have to walk across those ether. So you will have to change the code over here, and that'll lead to a lot of terrible mess. Do you see? Somewhere inside you, the algorithm used to solve this question is clear. Yes or no? You are clear with so and so is going to be the algorithm. But there is something which is a stumbling block in between you and the actual code which you have to write. Now, what is it that eliminates that stumbling block? That is called as low-level design. So using low-level design, you have to come up with a code which is extensible enough. Extensible enough means that in future, it can take care of multiple different vehicles. Even if the gaming company introduces new vehicles or new connections, then, the regular logic is not going to change. So if we have to attack this thing, then the very first thing, the very first step is to figure out that what are the things inside this that you think will change. Tell me. What all parts of this application will change? The first part is vehicle. Today you have a certain number of vehicles, tomorrow you could have more. Also, connections. Connections could also change. These are two things that definitely will change. Now, the principle of low-level design says that if there is something which can change, make it a polymorphic type. Polymorphic type means either an interface or an abstract class or something similar to that, which has multiple forms, right? Multiple forms. Like to give you a very simple example of polymorphic type, let me ask you a question. How many of you have used comparators while sorting? Have you ever used comparator? What is this comparator? This comparator is like an abstract thing. It's like an interface. And now you can write different varieties of comparator. So you can write a comparator which helps you to sort the array in ascending order. And you can also write a comparator which helps you to sort it in descending order, right? Why? Because comparator is an interface, so it can have multiple forms, right? So see, if something is an interface or something is a polymorphic type, let's say your vehicle is a polymorphic type. So in that case, if you declare a variable of type vehicle, then it can be made to point to a car. It can also be made to point to a boat. It can also be made to point to a tractor, to anything. Now, the only important requirement over here is that the methods that are defined inside the interface should be implemented inside these classes. So now we will move on to the coding part of it. So I'll stop share at this point of time. See, those of you who have little bit of idea around polymorphic types and all sorts of things like interfaces and abstract classes, it'll be super easy for you to understand. But let me tell you that even if you don't have that idea, I'll say a few conceptual things, and if you listen to them properly, you will be able to make sense of it. Okay. And now I share my screen. I told you that vehicle is something which needs to be polymorphic type, so it's an interface, right? Now, when you think about a vehicle, then it is a vehicle which is responsible to traverse through a connection, right? So what I mean by that is, if let's say this is a node and that is another node, and there is a connection. I don't know what is the type of this connection. It could be anything. It could be a waterway connection. It could be a roadway connection. It could be anything, right? The code will be in Java for now in this session. Okay. So if there is a vehicle over here, then that vehicle should, have some method associated with it. And that method I am calling as traverse. So there is an input called as connection, which the vehicle takes, and then it performs the traversal through that. As simple as that. Okay, cool. So this was our simple vehicle interface. Now this vehicle interface is going to have multiple implementations, because when you look at vehicle, it will have different types. So you have got a car, you have got a boat, and the way car traverses would be different than the way boat traverses. So all of them is going to be different. But this was our first interface. That's the point. Okay. Now, having declared this interface, we will look at another thing which was supposed to be extensible, and that is connection. So now you can look at connection interface. Okay. When we talk about connection, what is important thing about connection? Let's understand. So let's say this is a connection. Yeah, this is a connection. Every connection will have a starting island. So when I call a get start island, I should be able to get the start island. When I call get end island, I should be able to get the end island. Now, with respect to every connection, let's say this is a waterway connection. Now, when a car tries to traverse the waterway connection, I should not allow it. So let's say there is a method called as can traverse, which takes in car for a waterway connection. Then in that case, I should return false, correct? But let's say there is can traverse on a waterway connection and the input is a boat. In that case, we should return true. So I have got some methods like can traverse for car and can traverse for boat. Now these methods needs to be implemented inside the regular concrete classes, which will be implementing this connection type. Okay. Shouldn't we use can traverse vehicle? Yeah, I'll just show you. I'll show you that what is the problem associated with that. So let's try to understand that. So I'll tell you that why we have got can traverse for different concrete types. Like here you have got car, and below also you have got boat, right? Here also boat and here also boat. I'll tell you the chief reason why I have done that. For now, let's stick with the definition of this connection as it is. Now, think of it in this manner. Let's say instead of having CAN traverse for a car type, we had CAN traverse for a vehicle type, because vehicle is a generic type, right? In that case, would you have been able to implement it appropriately? Think of it in this manner. I'm just going to write some random code in comment section here. So you are saying that you want CAN traverse to operate on a vehicle type, right? Now, if you have to implement this thing, you will have to check what is the type of this vehicle. If the type of this vehicle, is a car, then you will run some other logic. If the type of this vehicle is boat, then you will run some other logic. Just looking at this abstract type, you cannot decide whether it can go through this particular kind of connection or not. That is the reason you actually need to pass the real concrete type so that you can determine whether it can go through this connection or not. Is it making some sense? Yeah. So that being the reason, the inputs that we have are boat, car, and all these things. Can we ensure that we always pass right object to right type of connection? There is nothing called as right here. These methods have to be implemented. Given that you have got a method called as CAN traverse, you can always return false. Okay, and you can implement the logic. We will see that logic which addresses your problem. Can that not be handled in the implementation of the respective boat or car classes? No. Let's understand why. See, so ये connection clear है ना? You understand this connection interface and the method that it has, right? So let's now look back at this vehicle. इस vehicle को फिर से देखते हैं. So inside vehicle interface, we had something called as connection. Now this connection is an abstract type. Okay. So if you take a look at some concrete implementation of vehicle, for example, car. अगर हम car को देखते हैं, then this car is something which implements vehicle. Because it implements vehicle, this car will have to implement all the methods that were there inside the vehicle. So vehicle ke inside, we just had one method, this, right? So we are implementing it. We are implementing it here. Now, do you see how we are implementing it here? First, we are checking if this connection can be traversed by this car. This is a keyword which represents the current instance. The current instance will be of type car. So when you call connection dot can traverse this, and if it returns true, then only you are doing connection dot traverse. Otherwise, you are not doing connection dot traverse. Okay. So I'll tell you what really happens here. Think of it in this manner. This car has a method traverse. Inside this method traverse, you will pass some connection. Now, it could be a waterway connection also, it could be a roadway connection also, it could be any kind of connection. Now, the moment you call connection dot traverse of this, what will happen? The traverse method, which is listed inside the connection or that concrete connection, will be invoked. Okay. If you first try to understand this, then your question will be automatically answered. Okay. So when you call connection dot traverse, then if you take a look at any concrete connection, let's say roadway connection, here you will have a separate traverse method that is there for car and another separate traverse method which is there for boat. Yeah. So there is a separate traverse method for car. There is a separate traverse method for boat. There are two things that are happening over here. The first thing is the moment you call traverse method on a vehicle, mano ek vehicle tha, V, you called V dot traverse, a certain connection, right? Now, if that vehicle was a car, what it will do is it will pass the car instance inside the traverse method of that connection. On the other hand, if let's say your vehicle was not a car, it was a boat. If it was a boat, it will pass the boat instance inside the traverse method of that connection. And now this traverse method can actually work in certain manner, because now it is sure that the input is of type car or the input is of type boat. Then only it can figure out whether this boat can go through this roadway or not, or this car can go through this roadway or not. This technique, it is a technique, it is a very well-known low-level design technique, and people call this thing, as I'm writing it here, this is called as double dispatch. Double dispatch simply means कि हम सबसे पहले क्या करते हैं, what is the first thing that we do? We invoke car.traverse. ठीक है? Car.traverse is invoked for a connection, and now on top of that connection object, we invoke traverse again by passing the actual instance of this car. Right? Think of it in this manner. Let's say you had a vehicle, एक vehicle का variable था v, ठीक है? And you invoked v.traverse for a certain connection, right? Now, when you invoked it, then what will happen? If that vehicle was of type car, then this method will be called and that connection type will be passed inside here. Now, because of double dispatch, this connection object will invoke traverse method, which is present inside it for a concrete type. Now, when the concrete type is passed, then some logic can be applied. For example, if you look at roadway connection, जैसे अगर हम roadway connection को देखें, let's say this is road, okay? So road के अंदर you have, every connection has a start island, end island, and roadway connection I told you also has a weight limit, ठीक है? तो roadway connection में, if you are calling can traverse for car, then what is it that you have to check? You just have to check that car ka weight should be smaller than equals to the weight limit. Then you can return true, otherwise you will return false. On the other hand, if this can traverse has been called for boat, अगर ये boat के लिए call हुआ है, in that case what will happen? In that case, you have to first check whether the boat has wheels or not, because it is a roadway connection, right? ये roadway connection है. So the first thing is that the boat should have wheels. And the second thing is that the boat ka weight should be smaller than the weight of that. So this is how can traverse is implemented for boat and for car inside the roadway connection. But if you talk about some other form of connection, जैसे कि let's say you talk about okay, by the way, are these implementations clear? ये can traverse यहाँ पे कैसे implement हुआ है? Is that making enough sense to all? Yes or no? Yeah. ठीक है. So now if you look at waterway connection, so waterway connection में, how should can traverse of car behave? It should return false, directly false, because car cannot go through water. And how should can traverse of boat behave? It should simply return true, right? So इसमें it would violate OCP principle if we check type. Yeah, but we are not checking type here. That's what I'm saying. We are not checking type. In the other case where somebody said that we can have can traverse for a vehicle, like if you remember when I was showing you this connection interface, so यहाँ पे somebody said no, that why not have a can traverse for a vehicle? If you have can traverse for a vehicle, in that case you will have to check whether this vehicle is of type car or not, whether this vehicle is of type boat or not. And there you will have to take decisions based on what the type is. Here, you don't have type checks. Here, you don't have if conditions. Yeah. If we use have vehicles and weight attributes in the vehicle interface, we can use a single function, but that is not right. Dekho, when you talk about vehicle interface, it should only have those things which are common to all the vehicles. Have wheels की जो हम बात कर रहे हैं, it makes only sense for boat, because boat के लिए have wheels attribute would make sense. It would be absolute nonsense for car or anything like that. है ना? So you can't. So that is the first thing. You can't have that thing over there. Does that make some sense? Okay. And also on top of that, agar let's say inside vehicle you have all those things, then in that case, the behavior of car and the behavior of boat, everything you will have to write here only. The reason we have made it an interface is because the things which are specific to car resides inside the car class, and things which are specific to boat resides inside the boat class. What do I mean by things? Things can be data, like here the data has wheels and weight, and there the data is probably just weight. So first thing is that data is different, and second thing is that algorithm could also be different, or the methods, like यहाँ पे you have got methods get weight, and यहाँ पे boat के inside you have got a method get weight as well as has wheels, which returns you the flag, the Boolean flag associated with it. Okay. Now just look at how the traverse method of all these concrete vehicles are implemented. So I showed you before also. Now if you again see, it will make more sense. So what we are doing is we are checking whether this connection can be traversed by this particular kind of vehicle or not. If yes, then we are going on to traverse it. Otherwise, we are not going on to traverse it. Okay. See, the thing over here was that we had multiple kinds of vehicles also, and we had multiple kinds of connections also. So we made both of them as polymorphic type, right? But the important thing was that in order to decide whether a connection can be traversed by a vehicle or not, you need to know the type of that vehicle. Because you need to know the type of that vehicle, you have to have a method somewhere which takes concrete type as parameter. That is the reason what we decided is the connection interface mein hum kya karenge? We will have can traverse and traverse method for all the different concrete types that we have, right? Is it like we are creating parent class for all the changeable variables, and under that class we have subject? No. I mean, parent class means parent class. It should just have things which are, which are common across all the children. That's it. By the way, so in the last few minutes or so, whatever we have discussed, this thing is a very beautiful design pattern. Anyone who knows about this design pattern, what is this called as? This is called as visitor design pattern. This is not strategy. This is visitor design pattern. So visitor design pattern, and the name also makes very much sense, where these vehicles are like visitors, and the paths that they are traversing, those paths could be different, right? So path or connection, whatever you call it, that connection could be different. So we made connection also as an interface, and we made vehicle also as an interface. But in order to actually decide whether a particular car can go through a connection or not, or a particular boat can go through a connection or not, we have got methods that take those concrete types as the arguments. So this was about this was the core design part over here. Whatever remains is very easy. But could you follow me on this? Could you follow what visitor design pattern is, and what was the idea of double dispatch, and how does it actually help us in solving the problem here? Now, the next thing we will do is we have built a class called as connection map. If you look at this connection map, this is nothing but this is just like an adjacency list only. ये बिल्कुल adjacency list जैसा है. Those of you who are good at DS Algo, you will be able to understand that. So if you look at it, let's say there is a graph. तो इस तरीके से let's say you have got a big graph. तो इसमें क्या होता है? This is an island, ठीक है? Every island has an ID. That ID could be an integer. और हर island से there are multiple connections that are coming out. ठीक है? तो जैसे if this island is island 1, तो 1 के लिए we will have a list which will contain 3 connection objects, this, that, and that. Now mind it, this connection could be any connection. It could be a roadway connection, waterway connection, anything, right? Similarly, for any other island, let's say this island is island ID 2, and yahan se you have got this connection and that connection. So you will have another entry inside the map, which will be 2, a list which contains 2 connection objects, this and that. Do you understand the purpose of this? ये कितने लोगों के समझ में आ रहा है? So this is just like a generic adjacency list. ये एक generic adjacency list है. Now why it is generic? Because this connection type is generic. अगर ये connection type generic नहीं होता, then it would not have been so generic in nature. Do you see the point? Okay, ठीक है. So you can see here कि inside this we have got a constructor जिसमें we initialize an empty hash map, and then you can add a connection to it. So let's say you are adding a certain connection which connects island 1 to island 5. Then the first thing we do is we figure out the start island, which is island 5. And then we check whether is map ke andar there is a key called as 5 or not. If that key is not there, that means we will initialize an empty list for that island. And then we will push inside that list. We will push inside that list the new connection. So this idea is this logic is very simple. This is just like, if you want to add new connections in the runtime, this method will help you to do that. Also, there is a method called as get connections. So here you can pass the ID of an island, and then it will return you the list of connections which are emanating out of it. Okay. So is this clear? Is this class connection map making sense to everyone? Why do we have it at all? Yeah. Okay. The simplest class that I have here is island. Each island has an ID. And I told you that har island pe there is a vehicle. And that vehicle could be any vehicle. That is the reason this is a polymorphic type being used here. Okay. And at each island, we also have connection map. Now, connection map is same. So it's the same object whose instances will be passed to different islands. Okay. So this is all about your island class. Okay. Island class may also you have a get connections. So when you call island.get connections, then what it will do is it will fetch the connections from the connection map, which is injected inside it. Okay. Okay. So we know about connection interface, we know about vehicle interface, we know about island, we know about everything that we were supposed to know of. Okay. So now we can do a quick simulation of whatever we have discussed. Okay. So isme I have built a very simple main method. Or isme dekho what I am trying to do. So inside this main method, the first thing I have done is I have declared a connection map. And then I am populating this connection map. So you can see, like as I am populating it, I'll also be drawing the corresponding graph. So you can see that there is an island 0. ये island 0 है, ठीक है? And यहाँ से this island 0 is connected to island 1. This is island 1. And that connectivity is through what? That connectivity is through, I think, roadway. So this is some roadway. And it has got a weight. You can see that weight there. Acha, island 0 to 1 is also connected by waterway. So waterway bhi hai yahan pe. Okay? Now island 0 to 2 is also connected, and it is connected by what? Sorry, it is connected by waterway. This is waterway. Assume it to be waterway. Okay. And then island 2 to 3 is connected by a roadway. So island 2 to 3 is connected by a roadway. So see, I can make a graph, no? ये जो गेम है इसके लिए एक जेनरिक ग्राफ मैं बना सकता हूं by using this connection map. In the future, the gaming company can choose to introduce new forms of connections, but this connection map will not change. It will remain however it is. Why? Because its dependency is not on different types of connections. Its dependency is on the generic connection, which is an interface. Okay? Okay. The next thing I have done is I have created some islands. You can see which islands banaya hai, और वहां पे you can see that these are the initial vehicles that are there. So as you can see that, I think you should be able to see the full screen. So yeah, है ना? And then for my convenience, I have done one more thing. I have created, this is just for my convenience, I have created a hash map in which there is an island ID and island object. So iske andar what I have done is I have, as you see, islands.put 0, island 0, 1, island 1. So I have basically put the ID of the island and the actual island object itself. तो ये सब यहाँ पे पास कर दिया गया है. ठीक है? Let me show you this function. After that, I'll answer some questions, and then after that, a lot of things will automatically start making sense. Okay. Now, when you look at this can traverse method, so can traverse method क्या करता है? Here I have passed. What I have to do is my start island is 0 and my ending island is 3. So I have to figure out whether I can go from 0 to 3 or not. 0 से 3 हम जा सकते हैं या नहीं, ये हमें figure out करना है. So I want you to take a look at the kind of connections that we have and the kind of vehicles that we have. Can you tell me whether it is possible to go from 0 to 3 or not? Island 0 pe we have got a boat. So I'll mark boat here. Island 1 pe we have got a car. Island 2 pe we have got a car. Island 3 pe we have got a boat. Is it possible to go from 0 to 3 here in this case? Yes or no? Just think about it. Yes? ठीक है. तो island 0 पे क्या है? Boat है. There is a boat, right? And the boat does not have wheels. And the boat weight is 150. अब देखो 0 से 2 there is waterway connection, and because there is waterway connection and we have a boat, so of course we can move from B to C, right? Now when we came from island 0 to island 2, तो island 2 पे क्या है? Island 2 पे we have a car, है ना? And the weight of car is 200. 2 से 3, the connection from 2 to 3 is a roadway connection, and the weight limit is 1010. Because the weight limit is 1010, can we traverse that? The answer is yes, we can traverse that because the car ka weight is just 200 units. So of course we can reach from here to here. But let's say it was just 101. So उस case में answer would have been true or false. उस case में the answer would have been false. उस case में there was no way out, है ना? Now the real beauty of all this hard work lies in this function. Look at this function, how it is implemented. It takes the current ID, the current island. Now this is a recursive function. You read it. You guys have already studied DSA. So if you understand this function on your own, you can type yes. And if you do not understand on your own, you can type no. Let's do that. Everyone seems to have understood. Now, do you see one thing, how clean this function is? Does this function have those Herculean if-else checks that we were imagining in our Google Doc? Google Doc में हमने जो इतने सारे if-else checks सोचे थे कि there will be if condition for car, for boat, for roadway, for waterway, for desert, for this, for that. All those things are there? No. Where is the real intelligence in this code? इस पूरे code में DS algo का intelligence कहाँ है? The intelligence of DS algo is present inside this method only. Backtracking or recursive logic is just present inside this function. Everything else that you saw, interfaces and classes, interfaces and their implementation, that was just design part. वो सिर्फ और सिर्फ design part था. Right? Now think of it in this manner. अच्छा, I'll explain this. हम यहाँ क्या कर रहे हैं? So you can see, let's say we are at a particular island whose ID is current. So वहाँ पे what we do is we figure out what this island is. I already showed you that there is a hash map जिसमें हम island ID, island object रखते हैं. Now, in order to get the vehicle, we can simply call i.getVehicle, है ना? And when you call i.getVehicle, I think something has got polluted over here. We'll have to do an undo. Never mind. ठीक है, तो I'll have to do i.getVehicle. उससे we will be able to get a vehicle, right? And when I call i.getConnections, तो उससे I'll be able to get a list of connections, है ना? अब यहाँ पे logic क्या है? If the connections is not null, अगर connections null नहीं है, तो in that case what do we do? In that case we iterate on all the connections. This is just like a standard, standard DFS. Okay, we iterate on all the connections and then we call v.traverse for that connection. Now here is where that double dispatch thing will happen. यहाँ पे क्या होगा? When you call v dot traverse of connection, it will simply go ahead and it will simply go ahead and exchange it. Yeah, now I think it's good. It will simply go ahead and do that double dispatch logic and check whether this vehicle can actually traverse through that connection or not. If yes, in that case, we now know that we have moved on to the other side of the connection, and other side of the connection can be gotten via connection dot get end island. So, I mean, this is the beauty of it, that this method has nothing to do with the different types of vehicles, or for that matter, different types of connections that are out there. Yeah. And this is what you will be expected to code in your LLD round. If it is a DSA round, you can code that dirty code also, where you have so many if else checks and all these things. But if it is an LLD round, the LLD round, even if you messed something in the backtracking part, but you were great at deciding the interfaces and all, you will get positive points. Do you see the point that I'm trying to convey? कितने लोगों के समझ में आ रहा है ये चीज? Yes or no? Yeah. So does that all make some sense now कि हमने इतने सारे interfaces बनाए और ये सब किया? So does that all make sense now? And now I'll tell you from the अच्छा, I think we have written this code, so I think we should run it also, है ना? तो 0 से 3 है. I think that graph has been removed, but I think you would remember that graph. If I run this code, so let's see what happens. I had put some print statements at different places, so they will be printed. And finally, a result will also be printed, whether it's a true or it's a false. I think it's building and it's now probably running. Yeah, so देखो, it said true. तो पहले it tried to traverse from 0 to 1 by boat, लेकिन 1 के आगे कुछ था ही नहीं. So the recursion went from 0 to 2 by boat and then from 2 to 3 by car. अच्छा, यहाँ पे अगर हम ये change कर दें, if we change this thing and then run this program, तो क्या होगा? All of you agreed that it would be false, right? Because now the road that links 2 to 3 is a lightweight road. It is of just 101 kg, which is smaller than, yeah, so you can see here, we went from 0 to 2, but we could not go from 2 to 3. So this code works well. Now, think from this perspective that there is a company, and in that company, there are two kind of people. So there are software developers. Software developers are the ones who are good with the idea of recursion backtracking and DS algo logic. They can even optimize this logic. They can even write BFS, DFS algorithm to optimize it, and they can get it working. And now, once this is done, then that company can say that now our project is complete, because now if we introduce new configurations, see, these vehicles are just like configurations, don't you think so? Because in future, if you have to introduce a new vehicle, then you don't need a skilled software developer to do that. Somebody can just see that, okay, there is an interface, so I'll code something against this interface. I want to introduce tractor, so I'll write public class tractor, which implements this, and it'll have its regular simple methods. No hard and fast algorithms. Similarly, if you want to introduce a new connection, you can do that. You can write a new connection class which implements this connection. So it means that this is a generic library that I have built. ये एक generic library जैसा हो गया, जहाँ पे कि I can introduce, I can plug and play with things. I can plug a new kind of connection. I can plug a new kind of vehicle, and the real intelligent piece of code, the recursive piece of code, which is this, will always continue to work. It will continue to remain however it is. This is the power of low-level design. Don't you think this is really the power? I mean, what do you say? In fact, it is. Whether it takes some time for you to digest this fact or not, this is what it is. When you use extensible libraries, pluggable libraries, तो यही तो होता है. This is what happens. है ना? So there are certain interfaces that you can code against, and then things work like a charm. Things work beautifully. You don't have to change the true thing, the actual thing that is there. Let's say somebody writes a Dijkstra's algorithm. किसी ने Dijkstra's algorithm लिखा है to figure out the lowest cost path. Will that Dijkstra's algorithm work for all the different vehicles and all the different connections? The answer is yes. And those uh, vehicles and those connections can even be coded by support engineers or program analysts, right? So now, if once this game is in production, then software developers do not need to be bugged again and again for new releases. The manager will probably reach out to analyst guys and all. He'll ask them that, hey, just introduce a new tractor or this and that, and they'll be able to do it, right? So this is what happens. And this is the trait of a powerful library, a generic library. You use a web framework. Why you use a web framework? Because it is designed in this manner only. Things are extensible. You just have to write few controllers and few models, and it just works like a charm. You don't know how it works, but because of things like these only, it works. Okay, I think this much should be enough for today. Okay, then great. So explore this and keep learning, and see you probably in some other class, which I'll be taking. Yeah. Okay then. Bye everyone and good night.